In this video, we're going to solve exponential equations without using logarithms. We've previously learned that we can solve exponential equations, i.e. equations in which the variable is in the exponent, by using logarithms. And that's true. However, sometimes we can convert the powers in the equation so that they each have like bases, and then we can make the process much simpler. And when determining the base to use in such circumstances, think small. Okay, so what we're going to do here, rather than use logarithms, we're going to see if we can work around that and not need to use them. So suppose we want to solve for x in the equation 3 to the exponent x minus 1 equals 9. Well, what we're trying to do here is get every term in terms of the same base. And the clue there said to think small. So the left-hand side is in terms of a base of 3. Let's see if we can make the right-hand side also in terms of a base of 3. Well, we can. 9 is equal to 3 squared. So what we have now is 3 to the exponent x minus 1 equals 3 squared. At this point, we can actually ignore the 3's and then simply state that x minus 1 is equal to 2. And that's what we get here. And when we solve it, we see that x is equal to 3. So if asked to solve this equation without using logarithms, we can say x equals 3. Now, just in case you're curious what the mathematical step is that we're doing here, when we say 3 to the x minus 1 equals 3 squared, technically what we're doing in the next step is we're determining the log base 3 of each side. Now, you don't have to write this step out. It's okay if you don't. But technically, here's what we're doing. We're writing the log base 3 of 3 to the x minus 1 equals the log base 3 of 3 squared. And one of the laws that we learned in an earlier video was when you have the same base of the logarithm and the same base of the exponent, that's the argument of the logarithm, the answer is simply the exponent. And the same thing is happening here. We've got a log base 3, and then the argument is a power with a base of 3, so we can say that that simply equals 2. Again, we said that earlier in an earlier video. You do not have to show the step I just showed. You can simply do it the way we did it here, but that's technically what's happening. So next question here, let's solve this for x. Well, we've got 2 to the 3x plus 4 equals 8 to the 2x. Maybe we can make each of these, each side, a power in terms of a base of 2. Well, 8 is equal to 2 cubed. So we convert 8 to 2 cubed and leave everything else the same. Now, when we have that power, 2 cubed, raised to an exponent of 2x, what we can do now is multiply those exponents. So 3 times 2x is equal to 6x. And now look what we have in this checkmarked line here. We've got a power with a base of 2 equaling a power with a base of 2. Well, we can simply let the exponents equal each other. 3x plus 4 equals 6x. Subtracting 3x from both sides and dividing both sides by 3 gives us our final answer. X is equal to 4/3. What if we have 125 to the x minus 3 equaling 25 to the 4x minus 5? Well, we can't make 125 have a base of 25 easily, but we can fairly easily make 125 have a base of 5, and we can fairly easily make 25 have a base of 5. So what we can do is see that 125 actually equals 5 cubed, and 25 actually equals 5 squared. Now we've got 5 cubed raised to an exponent of x minus 3. That means we've got 5 to the exponent 3x minus 9 because we multiply the exponents 3 and x minus 3. In this power, we multiply the exponents 2 and 4x minus 5. 2 times 4x minus 5 equals 8x minus 10. And so now we have the same base in each power. We can ignore those bases and just write 3x minus 9 equals 8x minus 10. And then we add 10 to both sides, subtract 3x from both sides. 1 equals 5x, and therefore x is equal to 1/5. if we have this equation given here, it's perhaps sort of easy to see that we can ultimately make the left-hand side an exponent, a power with a base of 4, and we can ultimately make the right-hand side a power with a base of 4 as well. So that'll be what we do. The third root of 4 is the same as 4 to the 1/3, and we're still raising it to the exponent of -5. Now, 1 over 4 to the exponent 6x minus 7 is the same as 4 to the exponent 6x minus 7 raised to the exponent -1. So this is where knowing your laws of exponents from grade 9 really helps. Now, on the left-hand side, we've got a power raised to a new exponent. So we're just going to multiply 1/3 and -5. On the right-hand side, we have a power raised to an exponent, so we're going to multiply 6x minus 7 times -1. 1/3 times -5 gives us this -5/3 right here. 6x minus 7 times -1 gives us -6x plus 7. And now we've got a power on each side with a base of 4. So we can ignore those 4's and write -5/3 equals -6x plus 7. And from here, it's just a matter of solving grade 9 style. Add 6x to both sides, add 5/3 to both sides. Ultimately, 6x equals 26 over 3, dividing both sides by 6, and then reducing our fraction. We get x equal to 13 over 9. Now, maybe we've got 7 to the exponent 5x minus 8 equals 1. I said earlier, when you're finding like bases on each side, think small. Now, this is actually an exception to the rule. When you see the number 1 there, that equals whatever base you're thinking of raised to the exponent 0. So in this case, we're thinking of a base of 7. So 1 will be 7 to the 0. Now, technically, this base, in our case 7, it can't equal 0 or be a negative number, but that's one of our typical qualifiers anyway. So what we're going to ultimately do here is just say 7 to the exponent 5x plus 8 equals 7 to the exponent 0, and then go from there. Okay? So once we have this line written here, we can ignore the 7s, say 5x plus 8 equals 0, and ultimately x is -8 over 5. Now, what if we've got this situation? 9 to the exponent 2x minus 4 times 27 to the exponent 3x plus 2 equals 81 to the exponent 55. Well, we definitely don't want to use a calculator here. 81 to the exponent 55 is just an unimaginably big number. But maybe we can make each one of these powers have a base of 3. So 9 becomes 3 squared. So right here where we have 9, that becomes 3 squared. 27 becomes 3 cubed, and 81 becomes 3 to the 4. Now, what we do next, we multiply the 2 and the 2x minus 4 to give us 4x minus 8. We multiply the 3 and the 3x plus 2 to give us 9x plus 6. We multiply the 4 and the 55 to give us 220. Now, what you see here, what I'm putting in those red square brackets, is us multiplying 2 powers with the same base. So laws of exponents from grade 9 tell us simply add those exponents. So 3 to the exponent 4x minus 8 plus 9x plus 6 equals 3 to the 220. Collecting like terms, 4x minus 8 plus 9x plus 6 is the same as 13x minus 2. So I say 3 to the 13x minus 2 equals 320, or sorry, 3 to the 220. And now we ignore the 3's and we simply solve. And ultimately, x is equal to 222 over 13. Okay. Now, this is kind of an interesting one. What if we have 3 to the exponent x squared minus 8x plus 16 equaling 81? Well, 81, perhaps by now you realize, is 3 to the 4. Maybe you have that much number sense. So what we can do is say 3 to the x squared minus 6x plus 16 equals 3 to the 4. Now we can ignore these 3's and simply set the exponents equal to each other. Well, if x squared minus 8x plus 16 equals 4, we can subtract 4 from both sides and make this statement. And then we can factor and get x minus 2 times x minus 6 equals 0, meaning that x is equal to 2 or x is equal to 6. Now, here's an interesting question. In this question here, we've got 9 to the x minus 90 times 3 to the x plus 750 equals 21. Okay, this is going to get actually really interesting. What we're going to do is we're going to get, we've got these two powers. We're going to get each one of them with a base of 3. So 9 to the x will be 3 squared to the exponent x. And 3 to the x will remain 3 to the x. And so we'll have both of our exponents in term with a base of 3. Okay, and when we do that, this is the line we left off at. Now, what we're going to do is we're going to set the right-hand side equal to 0, simply subtract 21 from both sides, and we get this statement right here. 3 squared to the exponent x minus 90 times 3 to the x plus 729 equals 0. Now, this is pretty clever, but check this out. If I've got 3 squared to the exponent x, that's the same as saying 3 to the 2x. Simply multiply those two exponents. Well, that's the same as saying 3 to the x times 2, which would be the same as 3 to the x quantity squared. So in other words, I can say that 3 squared raised to the exponent of x is the same as 3 to the x raised to the exponent of 2. So what we do is we actually take this term right here, the one I'm circling, 3 squared to the exponent x, and we call it 3 to the x to the exponent 2. Now at this point, you might be thinking, okay, why would we do that? What we're going to do next is we're going to let 3 to the x equal w. And if we do that, this part that I've just circled is w squared. This part here is minus 90w, and this part here is still plus 729 equals 0. And ladies and gentlemen, we have a quadratic. Pretty clever, okay? So that's what we show. Exactly what I just said. We let w equal 3 to the x. So this becomes w squared minus 90w plus 729 equals 0. We do our factoring and we say w minus 9 times w minus 81 equals 0. And we solve for w. It either equals 9 or 81. But we weren't asked to solve for w, were we? We were asked to solve for x. So we recall what w is. W is 3 to the x. So if I say w equals 9, I'm saying 3 to the x equals 9. And if I say w equals 81, I'm saying 3 to the x equals 81. And I'm going to solve both of those equations, as shown here. Well, 9 is the same as 3 squared. 81 is the same as 3 to the 4. So I can say either that 3 to the x equals 3 squared or 3 to the x equals 3 to the 4. Both of those equations can be solved by simple observation, and we can say simply, final answer, x is either equal to 2 or x is equal to 4. Okay, pretty clever. Now in this question, we want to solve for x where 3 to the x plus 2 plus 3 to the x equals 810. So what we're going to do is we're going to remember what 3 to the x plus 2 is. If I gave you 3 to the x times 3 to the 2, a lot of you would instinctively tell me, okay, sir, 3 to the x times 3 to the 2, that's simply 3 to the x plus 2. And for a lot of you, going this way and using the laws of exponents is pretty easy. Well, right now, I want you to use your creativity and think backwards. I want you to say that 3 to the x plus 2 is equal to 3 to the x times 3 to the 2. And so what we really have is 3 to the x times 3 to the 2 plus 3 to the x equaling 810. Now, the reason we're doing that is because now each of the terms, we have a term here, and a term here. And each of those is in terms of 3 to the x. Each of them has a factor of 3 to the x. So 3 squared is equal to 9. So I've got 3 to the x times 9 plus 3 to the x equals 10. Well, let's focus on the left-hand side of that line. 3 to the x times 9 plus 3 to the x times 1 is the same as 3 to the x times 10. Okay, I'm literally collecting like terms. So that's what I'm able to write in my next line. 10 times 3 to the x is equal to 810. Now from here, from this last line I just looked at, I can divide both sides by 10, and I can ultimately say 3 to the x is equal to 81. 81 is 3 to the 4, so we're saying 3 to the x equals 3 to the 4, so x must be equal to 4. Okay? And that's how you answer many exponential equations without having to use logarithms.